Okay, so today we're doing division of rational expressions. And so if you remember how to divide fractions, all you have to do is take the reciprocal and multiply, right? So you're flipping the second one upside down. So for our little study sheet notes for division, our first thing is reciprocal. So we do that even before we look for things like GCFs or factors. And then after we do that, we treat it just like a multiplying question. So we go, okay, do we have any GCFs? Can we factor? And then we get to look for those common factors. And I'm not sure why anyone's talking because I'm talking right now. Okay. And then after that, you get to do the multiply and simplify. So the only difference between now and what we did yesterday is we have to deal with taking a reciprocal. Okay, other than that, these are all the exact same steps we did yesterday. Okay, so let's do example B and C. Okay, so in this one here, the tricky things about these two questions is that we don't have just two terms, right? We have three. And so when you're taking the reciprocal, exactly. So we have to deal with our order of operations. And so in our first one here, we don't have any brackets or exponents, but the division and multiplication we always do left to right. So we're going to do our division first. So before anything, we get to take the reciprocal of that. So 6 over 5 times 10 over 9 times 1 over 20. And now it's just like the problems we did yesterday, right? So we can go, okay, well, 6 and 9 each can be divided by 3. 5 and 10. Divide both of those by 5. And so we'll say, okay, well, that gives us 2 over 1 times 2 over 3 times 1 over 20. And then we can say, oh, well, we still have more common factors. We can divide this by 2 and our 20 by 2. You could do it all together. If you're working with multiple different expressions, I would just recommend kind of dealing with them one at a time, because then you're less likely to miss something. But you could do them in any order, so you could deal with like the 20 first and then go back and do the 10 or something like that. Okay, and then this one can also be divided by 2, and we can divide this one by 2 again. Okay, so then that gives us 1 over 1 times 1 over 3 times 1 over 5, giving us 1 over 15. Okay. So C is a little bit different because we have the brackets. So because we learned our order of operations all the way back in, I think, about grade 7, we know that we have to deal with what's in the brackets first. So we'll just go 6 over 5 divided by, and we can't really divide out any common factors, so we're just going to go straight to 9 over 200. And then we get to go, oh, first step in dividing is we take the reciprocal and multiply it. And then we find those common factors. So I'll go, okay, well, I can divide this by 3, and I can divide this by 3, and we'll get a 2 and a 3 now. And then I can divide this by 5 and get 1, and divide this by 5 and get 40. Okay, so then easy peasy lemon squeezy, 2 over 1 times 400, or 40, yeah, over 3, giving us 80 over 3. Okay, so we're going to keep trucking along and work with monomials that have variables now. So we are just going to do B. Okay? So because of our order of operations, we want to work from left to right. So first things first is we're going to be working with these. So because it's multiplying, we can deal with it exactly like we would our multiplying questions from before. So we say, okay, we can't really factor these because they're monomials, but we can start looking for common factors. So we say, well, those x's can go. We don't have any y's, but one of our z's can go. And then, exactly, so we can go make this a 1. And when we divide by 5, we make it a 3. Okay, so now we have negative y to the third over 7 z squared. Nope, because the x canceled out with the x on top. Okay? So we have it like this now. Okay? So I would recommend that at this point, well, you can't do it with the 10x squared because this is still divided, right? Yeah, so that's one thing I was just about to say. I would recommend completely dealing with this before you start dealing with what's on the other side of the division sign. Okay? So by completely dealing with it, I mean we're going to multiply our first two terms now. So we'll get negative 2 y to the third over 21 x z squared. Okay? And then we can deal with it just like a normal straight up division problem. So the first step is to take that reciprocal. And we multiply it. I'm going to actually put it in brackets just so our multiplying sign doesn't get mixed in with our x's. Okay, so we take the reciprocal. And then we can start looking for those common factors, right? Because these are monomials, so we can't really factor them or take GCFs out. But we can say, okay, well, we have a z squared here. So we can take 2 z's out of the top. We have a y squared here. So we can take 2 of our y's out, leaving us with y1. Both of our x's are in the denominator, so we can't deal with those. But we do have a negative 21 and a 21. And we can divide our 2 and our 10 both by 2. So then we want to clean it all up. Pardon? You could divide by negative 2, and then you'd still get a negative on the bottom, though, right? So it's up to you. But either way, you're going to have that negative somewhere. Okay, so that leaves us with negative y over x. Our z squared canceled out with our z to the fourth. And then in the numerator, oh, not yet, one step ahead of me. Okay. And then we get to combine them. So because we have two negatives, here and here, we know it becomes positive. So we get yz squared all over 5x to the third. Okay? So these questions aren't really a whole lot more difficult than what we did yesterday. And judging by your quizzes today, you guys had a pretty good grasp on what we were doing yesterday. The only thing that I would say, well, not the only thing, but the trickiest thing about doing the division is we have to deal with our non-permissibles a little bit differently. So, for example, if we were to look at just this here, we would say that the non-permissible is that b cannot equal 0, right? And if we were to look at just this here, we would say, oh, that's easy peasy. D cannot equal 0. So if this was a multiplication problem, like if we had a over b times c over d, we'd say, oh, our two non-permissibles are that b and d cannot equal 0. But when they're divided, we have to deal with this as well, the reciprocal. So we also have that c cannot equal 0. So if you go to the next page, this is some quality study sheet material. So we'll have three places we have to look now. So if you look here, this is where we have to look for our non-permissibles now. Okay? So, and then they say, any variable which appears in the denominator at any stage should be considered for a non-permissible. So in our original and after our reciprocal, we have to deal with it. Okay? So for example, in example number 3, we would have to look at this, this, and this, and say that A and B do not equal 0. In B, we'd say this, 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 and this. Okay? So we'd get 7. We might. I'm pretty sure there's one in the homework. Okay, so here we get x, y, and z all do not equal 0. Okay, so for example number 4, we're just going to do B. And so for this one, if you encounter a problem where it's set up like this, like fractions within a fraction, I would rewrite it out so that it looks like this. Yeah, this is ugly and no one wants to deal with something like that. But when we rewrite it like this, it's like, oh, well, we've done this before. Okay, so what's our very first step when we are dividing two rational expressions? Even before that. Perfect. We want to take that reciprocal, right? So we go 4x plus 12 over 3x plus 12, and then we multiply it by the reciprocal. Like that. Okay. Now this is when you would look for your GCFs and when you'd start trying to factor things. Okay, so which one do we have? Oh, we have lots of them. Okay, so in our first numerator, we have a GCF of 4. And in our first denominator, we have a GCF of 3. Okay. Almost. And then in our numerator here, it's already factored, so that's nice for us. We just leave it like that. And in our denominator, we have a GCF of 3x. Okay? So the things we can cancel out, we have an yeah, you can change it to both. It's a good idea, actually. I will do that. Because I find you're less likely to accidentally cancel out both then. Okay? So I've canceled out the x plus 3s. I can cancel out one of our x plus 4s. And then we have, well, 4 and 3 don't have a common factor. We have an x in the denominator, but we don't have any x's that are separate from everything else in the numerator. So I think this is as good as it's going to get for us. So then we get to go, okay, well, we now have 4 times x plus 4 all over 9x. Okay. Okay. So both are right, like they're equivalent answers, right? So the reason I like to keep it in factored form is because if I forgot to cancel out a common factor somewhere, or you missed it somewhere and didn't see it, when it's in factored form, you can see that in your solution and you can cancel it out then. The thing is that in a multiple choice, A might have your answer written as 4x plus 16 over 9x, right? So you have to know both, and you have to, like, if you got this as your answer and you don't see it in the multiple choice, I would distribute that 4 and see if that's there. Okay? So now we have to find our non-permissibles. So we have to remember, okay, we look at our denominators and the denominator from the original. So we have to look at all three of these. So we can go, okay, 3x plus 12 not equal 0. So that's x cannot equal negative 4. And then x plus 4 cannot equal 0. So that's the same as that one. And then we have, if you look at this, remember this factored into two different things. So we have both 3x cannot equal 0 and x plus 3 cannot equal 0. Okay, so we get x cannot equal 0 and x cannot equal negative 3. Okay, so how we find our non-permissibles hasn't changed. We just have to look in one more space to find all of them. 0 comes from because you want to look at them when they're factored too, right? So go like this. Did it work? Dang it. Okay, so anyways. If you use the one magic pen, I'll show you. You can go like this. Isn't that awesome? Or you can go like this. This is the other one. I know. It's good stuff. Okay, so for example number 5, we're just going to do B again. Oh, dang it. Not the magic pen again. Okay, so because we have brackets, we're going to deal with that first. So we get to go. So 20m squared plus 30m over 9 minus 4m squared. So we'll deal with that in a bit. But right now we want to deal with our brackets. So the first thing we want to do when we're multiplying is we want to look for GCFs and factors. So we go, okay, well, we have a GCF of 11m first, minus 1. No, because it's brackets, right? So we want to deal with exactly what's in the brackets first. And then this is our favorite type 2 factoring here. So we get two things that add to negative 1 and that multiply to negative 6. So we get negative 3 and 2. So we get 2m squared minus 3m plus 2m minus 3. And that gives us 2m minus 3 and m plus 3. Okay, so if you are at all unsure about the factoring unit, I would definitely look it over before your test next Friday. Because if you can't factor, you can already tell that this unit's going to be a lot of trouble for you. Okay, so do we have everything in our brackets 100% factored?
Yes. No. Difference of squares.
Oh, good catch, guys. So the difference of squares is always hardest to catch when it has a 1 in it, right? Because that's kind of, we always forget about it. So before we multiply, we want to start canceling out common factors. So we go, okay, well, we don't have any lone m's in the denominator. We don't have any multiples of 11, but we can cancel this out, and we can cancel this out. 2m plus 3, 2m minus 3, we have to leave those. And that leaves us with 20m squared plus 30m over 9 minus 4m squared. And then you want to divide it by, so we'll go 11m, 2m plus 3, all over 2m minus 3. Okay, so now it's a dividing question we're dealing with. So we get to take that reciprocal. So we'll go 20m squared plus 30 over 9 minus 4m squared times 2m minus 3, 11m, 2m plus 3. Okay, so we know that we already have all of this factored because we did that in the brackets, but we have to work with this. So first thing we have to do is we get to take our GCF of 10m out. So we get 2m plus 3 multiplied by 10m. And then, even though it's a different form than we usually see, the denominator is a difference of perfect squares. So you get 3 minus 2m and 3 plus 2m. And that's all multiplied by 2m minus 3 over 11m. Yep. Like this one you could rewrite as 2m plus 3. But this would still be, if you were to rewrite it, it would still be negative 2m plus 3. So what would you have to do if you wanted to do that? Exactly. So let's do that right now. We want this in the 2m minus 3 form. So we divide it by a negative, and we make it 2m minus 3. So now we can start canceling things out. So we go, okay, well, 10 and 11 don't have a common factor, but those m's can go. We have a 2m plus 3 here, and we have one here. We have a 2m minus 3, and we have one there. So that leaves us with 10 over negative 11, 2m plus 3. Okay, because we still have this 11 here that we can't forget about. Okay, so for